Hi, everyone. I'm really happy to introduce you Krzysztof Cipora, who was really kind to accept our invitation for this workshop. So this is a 2-hour-long workshop, and Krzysztof, when you are ready, you can start.
So hi everyone, great to see so many people willing to do something with R. Just as a sort of disappointment maybe to some of you who are familiar with R, that probably you would not learn much, but it's meant to be rather the entry point, let's say, for very, very basic. So apologies to those for whom this is nothing new and nothing particularly exciting in terms that you know it already, but that was I think the plan and the intention to have it at a very basic level. Also, you can see in the chat that I first posted the link and then it was reposted by the main account that you can access the material for today. So all the slides, all the R documents are already there. If you want to kind of follow the flow, you can. At the same time, it might also be a bit frustrating to now switch on to installing packages or so if you haven't done it before. So then maybe it would be good that you just try to follow, and then the recording would be shared on YouTube as far as I understand, and it will be also possible to just kind of rewatch it and then try to follow the things. So let's move on. The idea is that we will have a quick overview of super basic concepts of R and how to do it, why to do it, why not to stick to the old school Excel way. And then I will try to show examples that we as numerical cognition researchers kind of encounter. We have a specific scenario or case one is that we just downloaded our results of our survey on Qualtrics, and it looks like a messy CSV file, and we want to get something out of it. And the other case is working with multiple log files. So for instance, imagine that you have conducted a study using PsychoPy, Gorilla, ePrime or other this type of software, and then you kind of end up with a folder of some structured more or less files, and you want to move on from there somehow. And of course, we all focus a lot of time and attention on doing proper statistics. This workshop is not on statistics, but it's more to show you some ways of using R, or some ways of searching online how to use R to get from the stage of getting the Qualtrics file or getting the Gorilla log files to the stage when you actually can do this statistical analysis that you want to do to test for your hypothesis or explore your data or whatever. So why doing this in R rather than Excel? You would see some clear benefits in terms of reusability of the script, that if you have nicely functioning script, you can do whatever you like with this. And what is even more beneficial in my view is the so-called reproducible workflow. So if you manage to, without doing things in Excel, correcting them in Excel or so, get from the Qualtrics dataset, for instance, the file that you downloaded, to whatever results that you wish to present in the paper, and it happens that, for instance, you started the analysis or so, and then it turns out that you speeded it up too much, and there were still some participants who filled in the survey in the meantime because someone didn't switch it off, and you see that, oh, I have 50 more participants. Doing it, let's say, in this click and drag things like Excel or so would imply that you need to do this entire pre-processing again to add these participants. Here, if you have a working script, what you do is you just rerun it with the file that you downloaded from the Qualtrics, and and you have the results already. Or for instance, you can start when you plan the data collection for 2 months, but you have some spare time in the meantime. You can just download the bit that you already have and start preparing the script to have it all ready, that when you finish the data collection, without any further view, you just download the very final file from Qualtrics, run the script, oh gosh, and then get the results. Sorry, I'm kind of lively in gesturing, and like my computer somehow detects my reactions, especially like thumbs up and stuff like that. And if you see like balloons around my head, that's because of this. So basic concepts of R. I don't know, could you, maybe we can do an exercise, raise your hand if you have worked in R at like any point in your life. 1, 2, 3, 4, 5, 6. Okay. Yeah, so there are some people who did some work with R, but some people who are new. So maybe we just explain this super basic concepts to those who haven't had chance to work with R. So in R, I would maybe quickly switch to the RStudio, the software we are using. It's one of the ways of like accessing R, probably the most user-friendly. What we do is that we edit the script, which is nothing more than a text file. RStudio is smart enough to highlight whatever numbers in different colors. If we put something in quotation marks, it would also highlight, it would prompt us if we miss a bracket or so, but the script is nothing more than just a text file. It has the extension R, but it's just text. Okay, and these are all the commands that we want R to do. And then if we want to get something out of this, to get some output, this output would be displayed in the console, which is just below. So for instance, I can write here something like 2 + 2, and then I run it using, on Mac, it's Command Enter, or on Windows, it's probably Control Enter or Control R. And then you see that it kind of console reproduced what I did, and it provided the result here. And it's more or less how R functions in general, that we have these two places. Here we can see what happens in our so-called environment, so which files are loaded to the working memory of the computer and can be like accessed, like data sets, functions, and so on. And here we have a list of packages which are installed. So that's like super basic introduction on how to understand the interface of R. Another thing, in R we have so-called objects, and each object can be, for instance, a data frame that is like a frame with data. This could be result of our study. This could be the thing that we are working on. We will see it in a moment. And then what is also very cool and which makes R so versatile are packages. So on top of like a regular R, like bare bones R, let's say, we have lots of libraries and packages which would allow us different things, from starting from like data manipulation, data cleaning, to very advanced whatever statistical methods, latent variable modeling, or whatever we ever wish to have. And we would today mostly work with packages called tidyr and dplyr. What it means, we will see in a moment. And then very important thing in R to keep in mind is the hashtag symbol, which is very powerful because it indicates the comment. So using the hashtag in front, I switch off this line. So this line I would completely ignore. But for us, it's very useful because we can use it to note what this bit of the R code does. So R will ignore it. These are not commands, but we can just read it that, okay, this is whatever, this bit will remove whatever empty cells from our data set or something. So comments are very useful, and then the more extensive you comment, the more likely you are to understand your own code if you come back to it sometime later. Then different types of data. So that's about whether these are strings, whether these are integers, and so on. R automatically detects what kind of data type is there in a specific column, in a specific variable, but sometimes it makes it wrong, and then this might cause problems, so you can always check it. Another thing, Google is your friend when it comes to R, and even pre-ChatGPT, which supposedly also can do R, but I never tried it myself. Usually asking questions in natural language in Google is very helpful, because you would end up with the Stack Overflow, which is like a forum for programmers, where you are more than likely that someone already asked the same question in a very similar way, and then someone was helpful enough to like answer this question, provide some examples. So you can use Google to your advantage when learning R. And this is how I learned. I never had any, I would say, serious course on R programming. So, and accessing help using, for instance, function, you can just write, if you want to access help about function, whatever mean, you can just type in your console $mean, and then you would see the information already available here in this like lower bit of the R studio. Okay, so that's a very basic intro. I put some links in the OSF project to some super introductory courses in R, where you can kind of learn this stuff. Yeah, because this is also not the time and place that we go through it like really step by step, because we would spend probably a couple of hours that you need to, that everyone needs to invest to get into R. So we would try to work with this like Qualtrics database first. It's like a sample study that a colleague of mine shared at some point when we prepared previous version of this workshop. So these are like columns described already in R, that some of them are not very useful, some like Qualtrics specific, let's say, things that it provides. And then these are the columns that are useful for us, in a sense that these are like those referring to the items of the survey. So this is just a list of columns. So I know that these are rows here, not columns, but this is like description of the columns in the Qualtrics output that you might have seen already. And what we would try is using the dplyr, which is so-called grammar of data manipulation, that would show us how to like, yeah, clean the data and make them organized in the more intuitive way. Another package that we will use is called tidyr, which is for this data organization even more than dplyr. And you can find these cheat sheets for both packages, which are very, very useful, very, very helpful. You can just Google cheat sheet, tidyr, cheat sheet, dplyr, and you will find it. And it's very intuitive and doesn't require too much reading to get into. So that's another thing that is worth learning, which is, I would say, more beneficial to human cognition than to R itself. It's called pipe operator, which is taking what is on the left and makes it the first argument of the next function. So using the pipe operator, for instance, here, what we want to do without pipe, if we want to select some columns from the data frame and then filter them so that we only select those the roles where the answer to gender was male. Okay, and we can read it from here, but the way the functions are kind of built one onto another, it makes them quite complicated. I mean, it's still readable because there are just like two functions put together, but you see that, okay, so filter by gender equals male. So we learn that this refers to this, then that this is about this data frame we learn from here. And what it does first to this data frame is selecting these three columns. Okay, it's still possible to figure it out, especially if you have some previous R experience, but using pipe, you can do exactly the same thing in a way simpler manner. So you say that you take the data frame, from data frame, you select columns called Q1, Q2, and Q1, Q2, Q3, and gender. And from result of this, you filter the rows for which gender is equal to male. Okay, so that's very much simplifying and making it more readable. As I said, it doesn't help R. For R, both are same and it's kind of neutral. But for the cognitive processes of the person like using R, this seems way more intuitive and makes this code also easier to read if I send it to someone else that they can figure out rather than jumping between the like phrases in brackets as you see in the upper bit. Another thing that we can, for instance, use pipe and the like dplyr and tidyr functions is the recoding variables. So for instance, if we have the column called gender and we have codes 1, 2, 3, and we want to replace them with the verbal labels, we can do it using the pipe operator this way, that we create a new table B, where we take table A and then use function mutate, which is super useful in terms of like changing variables, creating variables, and whatever. And we say that the column gender in our table B would be equal to recoded gender from table A, where 1 is recoded to string called male, the 2 is recoded to female, and 3 is recoded to other. Another thing that we might be willing to use R for our data preprocessing is switching between wide and so-called wide and long format. So sometimes it's more useful to have data in this long format if, for instance, we have measured 3 questions from the same participant, and then we can organize it in a way that we have participant 1, question 1, 2, 3 as separate columns, and then the next row is participant 2, and so on. Or we can have a long table with like participant ID repeated 3 times, question 1, 2, and 3, and values, and then participant 2 answers to all 3 questions, one under the other. So this data frames contain the same information. You can switch between them. And it's also very helpful to do sometimes because for some analysis or some processes, you need to have the data in the long format. Sometimes you need to have it in the wide format. Sometimes, for instance, if you do some, I don't know, if you have some log files that are organized as long data, you might wish to switch them to wide, or sometimes wide you want to switch to long if you want to run some linear mixed models. Using functions table pivot longer and pivot wider allows to switch between the two. So this is like very basic intro before we go to actual RStudio. Are there any questions to this? Okay, so I have a question to you. Is it more or less visible, or should I make it a bit bigger, like the font size and so on?
I think a bit bigger would be.
Okay, so you can also see that it's possible in RStudio. You go to View and you select Zoom In. Probably once more, you can also use the keyboard shortcuts, to which I like encourage. And we are working on the so-called markdown files, which are sort of files which apart from using conveying the R code, they allow also some formatting and so on and some text, and you can then save these files into HTML or PDF, and you also have these files with already the output also shared on the OSF. So how to read the things we are doing. So this is just a header of the document. We don't need to bother with this. These are just some like informations about the properties of the document. And then here, these are just section headers. And here we have like commented out. So this, if we run this bit of code, this would not be executed because we have hashtags in front. And here we have a code that we actually need to run. So for this bit, it's the scenario that we have a Qualtrics file. Okay, and then Qualtrics file, and then we need these packages, which we first of all need to install on our computers if we don't have ones yet. And to do this, we would need to run this code. I would not do it now because I already have these packages installed on my computer. But even though I have them installed on the computer, it means that they are just like lying down somewhere on the hard disk, and R is kind of not bothered with them. Okay. For me to be able to use them, I need to load them to the memory, like that they are within this R session. I can do it, for instance, by running this code. This would call the package called dplyr. So I can mark it here and press Command Enter using my keyboard shortcut. And we can see that library dplyr has been executed here. I can also like use, for instance, here, this function here to run it, run selected lines. Or the third way of like loading a package, if we don't want to like type, is we can also go to Packages tab here. You have then an overview of all the R packages which I have downloaded on my computer. Some of them are already pre-installed when you install the R itself, and they are some of them are like loaded when you like load R. Some of them need to be loaded. And they are more or less like alphabetically organized. However, and you can also, for instance, do read XL. We can go, if we want to, we can go here. Read XL, which is like serving to read Excel files. You can also get to the website of the package if in case you need. So you can also just press the tick here, and it's also loaded. However, I would not recommend it, because if I have it written and I run the script, they would be loaded. If I just select it from the list here, for this session of R, it will work, and I would use some functions from these packages and so on. I would be working on these packages. But then when I close R, I open it again, I try to run my script, I would encounter error messages that function this and this doesn't exist. Why? Because this function comes from the package that has not been loaded, because the code was not there, and what I did before was clicking here. Does that make sense? So packages allow to use some functions, and each package has some functions built in, but to be able to access them, you need to like load the packages, or at least call these packages like inside when you run a command. I will show it in a moment. Yeah, with packages, it's they are all free. You can download them and so on. You can theoretically load as much as you wish. However, this is not recommended. Why? Because there are lots of like these packages are created by different people, enthusiasts, whatever, activists or so, like statisticians working on different, data scientists working in different fields. So this is not a coordinated effort. What does it mean to us? It means that, for instance, there are functions which are named the same and do different things depending on the package. One function that I find for a good example for this confusion is a function called alpha. Quite legitimately in the psych package, which is used for psychometric analysis, function alpha refers to Cronbach's alpha when we calculate reliability of a scale. At the same time, in ggplot package, which is useful for creating beautiful plots, function alpha means the transparency of the layer. So if we want to make the points on our plot semi-transparent, we can put like alpha equal 0.5 and they would be like kind of transparent that you would see what is behind them. Makes total sense. In like computer graphics, this alpha channel refers to transparency of the object, but they are unfortunately named the same. And if you like have both ggplot and psych package loaded, the function alpha would be that the one which is active would be the one, I think, from the package that you loaded the first, but I'm not sure. There are some defaults, which one is kind of treated as the default. And then you can come up with having written beautiful code for like psychometric analysis to calculate Cronbach's alpha, and you use function alpha, but are things that you want to use the alpha from the psychometric package to calculate reliability. If you want to calculate reliability, but the active one is the transparency of ggplot, then you would see the error that this function doesn't know what to do. Even though the code to generate the reliability report is perfectly correct, like R is just confusing it because it thinks that you want to use the function from the ggplot about transparency, and the other way around, of course. So in that sense, it's first of all good to like install relatively few packages or load relatively few packages for each script, but also even if you need both psychometric analysis and transparency and making a plot in ggplot, you can still do a thing which we have, or we don't have, hold on, maybe not in the script. Oh yeah, here, such notation means that we specifically say that this is a function from the package called neat-r. And then it names the function. So in such cases, it's good to indicate for like the critical instances to indicate which package you mean to that R takes the specific function from. Is that kind of clear? Okay, so let's now start. In like normal R, rather than RStudio, you would have to set so-called working directory. Now, as we are using the R Markdown, the working directory is kind of set by default to the same folder where I have this script. So I don't need to specify which folder I should take. So I click, or like I highlight this bit of code and press Command Enter. What does it do? It uses function read CSV to like open a file called data_qualtrics_example.csv, and it says that like empty cells are those which are like empty cells, like that there is nothing, or where there is like a written NA inside those cells, and those would be both treated as like empty data missing cells with missing data. Okay, and we see that this, and we tell R that the effect of this, like reading the file, blah blah blah, should be allocated to object called main data. All right, and we see something here which is called main data. We can view it if we just click on it, and we see how this looks like. So we have some stuff here, and these are probably our participants. And we can also see how big it is, that we have 47 observations, that is 47 rows, and 30 variables, so like 30 columns. You can also import Excel file rather than a CSV file using the function called readExcel from the readExcel package loaded above. So that would be also possible. So we can tell that it's like function called readExcel. Excel file name is provided, and then we say that we are interested in the sheet 1 of this Excel file. Some people say that it's okay to use Excel. Some people would say that, yeah, well, it's maybe safer to stick to CSV or text files because like the formatting and so on for R may cause some problems down the road, and it's safer to just stick to the plain text. Yeah. And after we import this data, so we have, yeah, these are both the same. After we import the data, we can check and like visually inspect what we have there. And here are some functions that we could do. For instance, head from main data, that's like a function called head, is displaying first like the first 6 rows plus the column names. Here it's like this. It's the R Markdown feature, but if we do it in plain R, let's do it in plain R. I will just copy it, paste it to the console below. And this is maybe not very useful because the headers of the columns are very long and it kind of wraps it. It contains the actual questions from the survey, but we can see the column names and first rows of the data set. We can also print the like tail, that is the 6 last rows in the, or 5 rows in the console if we run this. So this is like the ending. It might be useful because sometimes the last ones are somehow missing or so, and we can have a glance at this. Or we can also use the view function, which essentially does exactly the same thing as clicking here. Okay? So this gives us a sort of insight into what we have in our data frame. But there are some other functions, like one of them quite useful is called glimpse. And for glimpse, we have a bit better overview of what is there. So we have the like variable names here. And then we have the values of the following rows, like one after another. This is not super useful given the arrangement of the Qualtrics data that we have this like imported but we would get rid of it in a moment, and then it turns out that this function is a bit more helpful. Okay, and then like an example of this pipe operator, which we will use in a second to do some like further stuff with cleaning our Qualtrics dataset. So pipe, we can, it doesn't work in a plain R, the pipe that we use this like percent, then this sign, and then the other percent. We need either dplyr or tidyr to make this work. Okay, so to get this function of like exponent of 2 and then sinus of this and then logarithm of the result, we could do it like this. However, this is also not super easy to read, right? With pipe, like for R, it's the same, like the operations it conducts are the same, but then we see there is some, the code is much simpler, that we go from like number 2, then we get the exponent, sinus out of this, and then log out of the result of the previous. And as you can see, we end up with exactly the same solution. For R, it doesn't matter. For us, I think this is like way easier to understand what calculations in which order have been done, let's say. Oh, someone is texting, but sorry. I didn't know whether it was the chat of the Zoom call or. Okay, so how to clean a Qualtrics data set? So first of all, it's important to remove this like first and second rows of the data set, because they are, as you see, this is just a duplication of this, and here you have some like Qualtrics explanations of these variables. So we don't need it. This is not data from participants. It's just how Qualtrics files are organized when we download them. Another way of doing that is using a dedicated Qualtrics package, which is like which would let you import this directly without the necessity to like slice it to do the thing that we are doing now. But let's do it this way. So we use the new data, and then this means that we allocate to a new object which doesn't yet exist, new data. We allocate that it would be our main data. Okay, so the thing we have already. And then we say that we get rid of the first and second row. And we see that new data has only 45 observations and 30 variables. So the number of columns didn't change, the number of rows changed. And let's have a look at it, at new data. And here we see that the column names are already way more useful than they have been before, right? And then we see that the actual data, the actual responses from the participants start from the first row. Okay, then probably we would like to rename the columns. For instance, this one looks a bit annoying, and it's not only about the elegance, but also about the role that we would need to name this column if we want to calculate an arithmetic mean of this or anything, and then we would like to have the names a bit more consistent, intuitive, and so on. Because if we make a typo, then we get an error. So with this one, we can see how to do it. So here you see that we don't create a new data set, but we just like overwrite the one we already have. So we have a data set called new data, and we tell that this new data should be the new data, but with this function applied, that we have a rename function where we say that the column duration sec is equal to duration in seconds. So we just rename duration in duration dot in dot seconds dot to duration sec. So let's run this. And then we can look up what happened. We have this way more intuitive name here rather than this one with like 2 full stops in between and somewhere some other like somewhere in between. So like this is how we can rename our columns to make them more useful, sometimes maybe shorter, sometimes maybe more intuitive. And then what we can see here also in our new data, that quite a lot of this are some sort of like Qualtrics or whatever other software you use. It's not like Qualtrics specific by no means, but there are lots of columns which are not useful at all. Or they might be useful for some like diagnostic purposes, whether the program worked as it should, but it's not something we would use in our analysis. So what we can do is we can say, okay, again, we overwrite the new data with a new data, but with these changes. That is, we select. And here we just list in like comma separated minus recipient last name, recipient first name, and so on, which means that we kind of select everything except the columns listed here, which is indicated by the minus. And then, of course, if you want to learn something about the select function, you can just type select. And then you can see how this can be used. So it's not that everyone needs to memorize everything, but you can have like different options how to use this function from the depler package. You see that it's like the function from depler rather than any other. And then you can see different ways of selecting. So you can select everything, you can select except something, you can list which ones you select, and so on, or like from to the left from this and stuff like that. So that's how we do it this time, that we just use the minus sign and we skip the columns. So now we look at the new data. It has like 30 variables and 45 observations, and we have like 1, 2, 3, 4, 5 columns that we want to skip. And then we just like press here, we run this code, and we see that we have 25 columns left only. So in R, it's kind of useful that you can create this like pipeline of analysis. You can skip some columns and so on and so forth, and then do some other stuff with your data. But then you kind of do analysis, and here you figure out, oh, I would really need this column that I deleted. If you did it by deleting the column in Excel and then doing some other operations there, you would be, and then also selecting some participants or so, you would have really hard time to bring back to the moment when this column has not been selected, when you were also excluding participants who didn't finish the survey and so on. You would have to click through everything to get to this stage again. If you, for instance, at this stage decide that, oh, I would rather need this variable to be there, you can come back to this stage, which is here, whatever here, and just remove this bit of the code, rerun everything, which takes probably 2 minutes or so, and then your variable would be in the new data set, this variable would be retained. Does that make sense? Is that clear? Okay. And then what is also quite funny is that using the pipes, you can essentially like combine all this into like one line of code. This does everything we did so far. So like the slicing, renaming, and skipping the columns. So the result of this is exactly the same as result of the previous ones. Some people would say that this is maybe better to have like whatever better documentation what has been done. At the same time, this is still readable because you see that, okay, it first was slice, then rename, then select. So you have it all in one place. And again, if you decide at some point that I don't really want to skip the external reference column, whatever that column stands for, you just delete this one line, rerun everything, and you end up with the the end result, which is just considering this column and includes all the other steps that you have taken so far. Another thing is important here in R, I mentioned it already, that the type of the data is correct. So there are various types of data in R, for instance, character, so like rather letters, or so numeric, which is like the ones with the decimals, integers without decimals, and it is essential to ensure that the data analyzed is of the right type. And sometimes if you have like weird error messages, it can be because of the you thinking that this is a factor, but R thinking that it's numerical, or you thinking that it's numerical and R for some reasons thinking that it's character, and so on. In our data set, all the variables were originally treated as characters, and we can use the function asNumeric to convert the numerical value into numerical data, and the function asFactor to convert some of them into factors. So in the following, we would convert the key variables into their correct type, and then the function mutate would create the new columns or modify existing ones. So here, it's modifying the existing ones, that is like overwriting them. At the same time, you could also just create a new variables. So what it does here. So we take the new data, which is our new data, with the function mutate applied. So we have duration in seconds would be asNumeric duration in seconds. Finished as factor finished. Gender as factor gender, age as numeric age, and so on. So you change the different types of the data, and then we can run it. And then glimpse function would allow us to see what kind of data types are there. So that's very useful. And also this mutate function is useful also for other stuff. For instance, we can create a new variable, which is the sum of 3 existing variables. So for instance, if we have 3 questions with a Likert scale, and we want to create a sum, we can use this command, new data, and then new data, mutate, Q1 to 3 total equals Q1, Q2 plus Q1 plus Q2 plus Q3. And then we see that we have 26 variables now, and we see that this is the sum of this 3 Q1, Q2, and Q3. And we can also create a new variable, which would be the variable called participant ID, which just corresponds to the row number in the data set. So that's a sort of another use, and this mutate function is extremely powerful. And also the way you kind of feed this function is really really intuitive and simple, I would say, compared to other ways of doing similar things in R. There is, of course, like to dplyr, to tidyr, also the help and support online, and the online documentation and help for these packages is just amazing in a sense of like accessibility, how it's like easy to read and easy to understand for non-programmers. Here we can also create a new variable which takes the value true if a participant is primary school teacher, that is in the level taught they marked the they selected the response number 2. And then we kind of contrast them against like everyone else. And then this is what we do. And then we have primary teachers, true, false, and A, because there was like nothing. And then what is also very, very important in R, especially if you don't have experience so far, it's very important to know this symbol, this kind of, and the minus stands for like allocating or like assigning one thing to the other. In several contexts, this is equivalent to the equals. So equals, symbol equals, single symbol equals doesn't mean like equals in the mathematical sense. It stands for like, again, assigning. So like primary teachers would be assigned the level taught equals to. So the double equals, like this one, is like for checking whether like the left side is the same as the right side, if that makes sense. So to have a logical function to check whether, I don't know, gender equals female, we would say gender equals F, right? And then the result would be true if that's the case, and false if it's not the case, okay? And if we just wrote gender equals female, we would like replace all female with the string gender. Does that make sense? So sometimes if you like write this like logical formulas to check whether something is equal to something and it suddenly doesn't work for some reasons, then double check whether you are using the proper thing, whether you are using double equals for the logical formula to check whether something is the same as something else, or you want to allocate something to become something else, and then you use the single equal sign. Here, another exercise to create a variable which takes the value long if the participant has more than 10 years of teaching experience, otherwise it takes the value short. So again, we use the mutate, and then category teaching experience, and then as factor, we need to change it to factor, and then if else. Teaching experience is great value of the variable year teaching experience is greater than 10, then allocate the value for the new category teaching experience column to be long, otherwise allocate the value short. So if we run this bit, we would see in our new data that we have these strings here like short, long displayed, and the value here, whether it's short or long, depends on the value in this like teaching experience column. And then another thing that we might use, and that's kind of helpful, is recoding the values of variables. So if we want to recode the values of 1 to 3 to male, female, and other, we could do it using this bit of code. And then we end up with this rather than the numbers we had before. And this function recode is also helpful if you want to reverse code the variables. If we have like an item in our questionnaire that we want to switch the values around, one way of doing it would be like this. So we have like new data. We say that like we have a new data, and then we have the pipe, and then again mutate, and then Q1R equals recode Q1, and then we just tell what to recode into what. And then maybe one question to you to kind of like increase engagement. Will this create a new variable or override something else, and why? And what would determine whether like creating new variable happens or overwriting happens?
Sorry, can you repeat the question?
So sometimes such code may lead for a new variable to be created. And sometimes it would be overwriting the column that already exists. What would determine whether we create something new or we overwrite something which is there?
There are some responses in the chat.
Okay, I cannot see the chat, so hold on. How can I see the chat here?
I can read them. The variable name are different, so a new variable.
Yeah.
Ilaria says 1 equals creates a new variable. Tatiana says you have to use double.
Yeah. So for here, I think the answer that I would sympathize the most is that if the name is already there in the data frame, then we would overwrite, right? So here, for instance, gender equals gender, we overwrite. But if we created something like gender recoded, such a column doesn't exist in our data set. And if we run this code, we would create a new variable called gender recoded. Okay, so, and this is more or less automatic, and this is also kind of important to keep it in mind that sometimes you wish to have it overwritten, not to multiply, to have, I don't know, gender row, gender recoded or so. But sometimes if you have, for instance, questionnaire with like reverse coding items, it might be a bit more useful to do it this way, just because you never know when you overwrite, you never know whether you have already like flipped the coding or not, right? And then you would just be flipping from like one to the other each time. While if you have a separate variable, then you know, okay, this one is the recoded one and this is the original one. But it also depends, of course, on like your specific workflows and so on. But it's also, but what I want to encourage you is to keep in mind that there are these two ways, and then choose the ones that will make you less confused and will make also less confused people who will be using your script and your data in the future. Okay, and then getting more or less close to like finishing this bit is about filtering rows. So sometimes we have some observations that we don't want to consider. For instance, in this survey, if someone just like rushed through it, probably without reading, because we know that it would take longer to whatever read with some. some sense, or we want to exclude participants because they don't meet our inclusion criteria, but they filled in the questionnaire in any case, in any ways, we can use this one. So this again is like overwriting the new data, applying filter that only those for whom the duration in seconds was greater than 180 would be retained. So let's have a look at this, and let's have a look at the new data here. What happens? Here it changed from 45 to 40. So like 5 participants were like rushed through the survey, and therefore we think that they maybe didn't read equivalently, we could also exclude rows where duration in seconds is less than or equal to 180. So this is like exclamation mark indicates the like negation, right? And then we have also like the same thing happened actually. Because this is like, we keep longer than 180. And here we exclude everything which is shorter than 180. Shorter or equal to 180. We could also be interested in discarding or not including participants who are super fast, who just rushed through it, and also those who have taken very long time to do the study. So here we use like and then we filter those who have been like, we only include those who were like slower than 180 seconds and faster than 3000 seconds. And then we didn't exclude anyone else, so it seems that we didn't have anyone who was super long. And then we have also some missing data, and there are of course like tons of ways of, is it a question or? I can see a reaction in, okay, no.
I think it's a thumbs up.
Okay. So there are of course like various ways of like dealing with missing data, and it's not like telling you which way to use, because it's like science on its own rights. But like one way of deleting the or like dealing with missing data is just to exclude participants who have missing data. So for this one, we could just as you see, we do not allocate this new data to anything. We just want to view what happens if we do this like drop NA to new data, and this is the one. You see that it ends at 30 observations. So it excluded like all the participants who had missing data somewhere. But as you see here, we didn't allocate this, we didn't assign this to be like another R object, or we didn't tell like new data, R row, new data. This is just to display it. It doesn't like store this anywhere or so. Another way of doing this, like cleaning or removing the observations with missing values, is to specify a columns where we are interested in the missing data, right? So we are not maybe interested in like excluding all the observations that have any missing data, but I don't know, question 3 in this case is our crucial one for the study. So we want to discard all the observations which have like NAs in this one. So we can do it like this. And then we see that we just skip only one participant because we ended up at 39 rows. Again, we didn't assign it to any object. It's just like how to show the how to do this like skipping. We can also drop NA based on like missing data in any of these three Q1, Q2, and Q3. And if we do this, we see that we end up with like 35 observations retained. So that's somehow useful. And also just to remind you, like having all this written as a script, even if you don't have such extensive comments as I have here, gives you like a very good track of what you excluded, why you excluded, how you excluded. And if you used Excel, which I did for like quite a long time, because this is how we were trained, then you kind of lose it unless you write a kind of log in whatever Word or text file in parallel to doing things with the columns. Here you just have it in one place, and I think that's the great value of doing this like reproducible analysis with R. What else? Summary statistics. We can calculate such a thing, that is, we summarize the mean and standard deviation from Q1, and we end up with these values here. So we use like new data, and then we use the pipe to use summarize, and mean Q1 equals mean Q1, remove the missing data for like averaging, and SD Q1 equals SD from like, again, the same column, removing the missing data. Here we could use also a function count to count the number of rows in each unique value, the variable. So here we would see like teaching experience, we see like long and short. If we run this, in the console, the table would be maybe a bit less beautiful, but equally informative, I would say. So here you have the same like category, teaching experience, and N. So if you use like R script rather than R Markdown document, you would also get it, but in this format. And you can also combine these with a group by function, which allows to computing like summary statistics for groups, for subgroups of participants. So for instance, here, we combine the summarize with the function group by. So we first group by gender, and then summarize by calculating this mean and SD here. And what happens? We have like split here like male, female, and then the values corresponding to these groups. We can also calculate easily using the same way other statistics such as mean, like median, maximum, minimum, sample size. In the following, we return the sample size, the range, and the median. So we have like summarize, and then we have listed like N equals, and this is like the N, how we get the sample size, how we get the range. So we just calculate the difference between minimum and maximum, and median. And we have everything also like grouped by gender. It's also possible. So this is kind of like the moment when you start thinking of it as like a bit of a jigsaw puzzle, that you have some blocks and you can put them together to get into the result that you need. So for instance now, and this is I guess when the actual fun with R starts, when you learn to combine it, when you get some experience, and it comes with time. It takes some time, but I would say that shorter than you would expect it to take when you see it for the first time. So that's why I really encourage to do some practice and give it a go. So here, maybe let's do it in the console. So we have like two categories. So we have like, this is split by both gender and teaching experience. And then we have the mean and standard deviation for each of this, like male short experience, male long experience, female short, female long. So that's, I would say, quite neat. We can also do it with the count function. Okay, the question, very good question from Ilaria. Are those outputs saved anywhere or just visualized in the console? So if you use the markdown, you would have them saved in the document when you do this like neat thing. If you are using the like running the script, they would be displayed in the console, but then you can also like allocate it to be a data frame and then save this data frame or save this table as a text file to as a text file or as a CSV or something. So that's like one way of doing this. Another way, which I found at some point, was that you can kind of force R to send every output from the console to the text file. It's Googleable. I don't remember how to do it at the moment, but it's Googleable. And if someone knows it by heart, then please just type it in the chat. And then we can reshape the data set. So we want to change it from the wide to long format. And then we use it. First, we need to select the data that we want to like flip from the long to short, from the wide to long, as I showed in the slides earlier. And then these are the isolated columns, let's say. Yeah, that's the cat function. Yeah, thanks, Lily. Yeah, so here we just isolated in the table wide the columns that we want to flip into the long format. We still see that that the participant code is like like that one participant corresponds to one column to one row only. And then we want to do it to switch it to the long format. And let's do it then. We use the pivot longer, then we say that columns are like Q1, Q2, and Q3, names to question, values to value. And let's see how this changed, and then like try to backtrace what the bits and pieces of the code did. So this is the table wide. We have Q1, Q2, and Q3 as the column names and participant IDs here. In our long table, participant ID is repeated 3 times. Question, we have a new column called question, and then it goes to like Q1, Q2, Q3, and we have value of 0, 3, and so on. So what happens? Names to question, so the column names from this have been flipped into like values of the column called question. Okay, and then values from inside this table, they have been moved to the column called value. So it's very similar to like doing pivot tables in Excel, but then we are using code here. And it's also possible to like switch from the long to the wide table. And this is also something that we will see in the second case. So now we flipped it again. So we did like a table long, pivot wider, names from question, values from value, and then when we display it, we kind of came back to the table wide. So it's like really, really quick and neat to do such transformations. And then how to sort the data. It's sometimes useful to order rows by value. So we can use the function called arrange in like ascending order or in the descending order. Yeah, so that would be the first bit on like how to deal with like Qualtrics data when we have like one maybe a bit disorganized data set and we want to bring it to the format that we want to analyze. And again, one option would be that at this stage we just save this Qualtrics file into like text file which already has like nicely organized data set, blah blah blah, whatever. and then we do the analysis, the actual analysis, like codes for correlations or so, in a way that we load the data from this neatly organized new text file, which is like what some people would do. What others would do would be just to continue the script that you go from the Qualtrics log file to beautiful correlation matrix that you can copy and paste to the paper. Probably people more skillful in programming can advise like which one is more useful to do and which one is more efficient. I can imagine that at level of being like amateur programmer or like amateur data analyst, it's mostly due to your individual preference. Maybe if there is like really lots of time spent and lots of like computational power spent on like doing this pre-processing, it might be worth to save the file at the end and then go from this one. I don't know. That's, I would say, fairly up to you. Are there any questions about this? Okay, then we have still the Qualtrics, this is a bit shorter, how to deal with the data from like PsychoPy or so, but I would suggest that we maybe take a 5-minute break or something, that we just have a bit to whatever vent or so. Is that fine?
Yeah, good plan.
Or in case there are questions or comments or so, just please like drop them in the chat or ask, or I just need to refill my water bottle. But
Sure. So let's meet back at 25 and have a bell break.
Shall we continue? I don't know. I just told 5 minutes, but I didn't look at the watch. So Can you like
I
give like your hands up whether you're ready, or like is someone taking the time maybe? Or...
So I told them we'll start again at about 25. So
okay, so
we
like
leave
few
it
more
a
minutes.
couple
Okay.
more minutes.
Yeah, no worries. I just didn't know how.
I think we can go ahead and get started again.
Okay, cool. So I don't know whether this has like come across already, but I mean this workshop is not meant to like solve all the problems, of course. What I want to encourage you is to like give you something which is like similar to what numerical cognition researchers can encounter. Start playing around with this. Hopefully it works on your computers too. And going from there, like getting through the like Stack Overflow documentation of dplyr and so on, just learn it yourself step by step. I will also show it here that like there is like one bit of code that I cannot really explain you like what it exactly does because I don't understand the syntax. I just Googled it, found it, tested it, and it worked in a sense that it did what I wanted it to do. And this is to a degree, I think, experience that you gain, that you kind of copy paste stuff from Stack Overflow. And then the more you do it, the more you understand what you're pasting, and then it's kind of getting there. If you have had any like courses on R that you followed, good for you. Or if you have like some programming experience before, I never had one, and I can also tell like how how my R experience started. It was lots of like, I would say, blood and tears involved. That I was revising a paper when first I worked with a collaborator. He did his bit, and then I was doing my bits in Excel. And then this paper was like dumped for many years. And then it was like, we submitted it at some point, we got reviews, and I was like revising the paper, revising, and then I found this moment there that we like generated the data using R, blah, 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 and the rest was done with like pivot tables in Excel. And I thought, okay, yeah, well, that doesn't sound very good and professional. It was quite a lot of implementing formulas, aggregating the data, and so on. And I just thought, okay, yeah, well, it's a bit shame to have it done like this. Let's do it in R. So I had lots of stuff that I've done in Excel. It was quite some years ago. And I just wanted to translate it to R, knowing like roughly that you need to put some code into the script and run it and see something in the console, and then something happens. That was more or less my knowledge at the time. And I just, was spending long time Googling and checking and testing for every single line of code. I could double check it, whether it kind of followed the results I got from Excel. So I had some reality check that I'm not doing random stuff there. So that was it. And this is when I kind of, after this painful, maybe 2 weeks of like trying to build the code, I started understanding more or less how it works and implementing it more and more into my workflow. So I don't know whether it's the best way. It's probably a survivor bias, what I'm telling you, but it's certainly possible to learn this way. Of course, if you have like chance and possibility to follow formal training in programming, that's great. But yeah. This is also maybe why, if you did such a formal training and you see the code, you can think, oh gosh, it's so messy. It's probably possible to do it in a way more professional manner, that it's, I don't know, simpler, smoother, and maybe you could save 10 milliseconds on the execution time if you optimize it. But if you're working on more or less not super extensive data sets, like it's still doing it at this level and having the script that you can refer back, I think it's already a couple of like levels higher than doing things in Excel, reshuffling columns and so on. So yeah, that's it. Now imagine another scenario. Before we had like Qualtrics study, questionnaire, participants responded some like questions, and then we want to see whatever, like be ready to run some correlations on it, let's say. This is another story. We have an experiment that we run in PsychoPy, and we have multiple result files, like one file per participant. In this task, children solved a series of arithmetic problems, with like some of them being carry problems, some of them being non-carry problems. And we want to know each mean accuracy for carry and non-carry problems for each child, also the mean reaction times for correct responses, and how many trials are included. So our files are stored in a folder called raw data, located in our current working directory, and they are all stored in the format of CSV. So of course, this applies to also like programs like ePrime, Open Sesame, or so, that you have at some point very structured CSV file presenting tons of columns which are completely irrelevant because they are just logs of whatever display properties and whatever, how memory reacted to what the program wanted to do, to some very relevant and what was presented, what was the reaction time, and what was the accuracy of the participant. So first of all, we need to load the data. In old times, I was using something which was called Excel merger, putting the files and kind of like pasting it together. Lots of mess, lots of manual work, clicking, and space for mistakes. And until I learned that using this code, you can actually put the files together. So what we do, this command says list files which are in a folder called raw data, stored inside the folder that we are in. Okay? And we are interested in the files with the name pattern of star means like something dot CSV. And then this full names equals true is like doing something. Probably to consider the full names of the files in the when we load them to R. And then we kind of change this. So we do this. And now we have a list of like files which we have in the folder. And if we look it up, that's the folder that we are in. And we have a subfolder called raw data. And we have the files called part 01, part 02, part 03. Okay. So it listed them here. It tells that there are 3 of them. And now we do this, which again, that's the bit that I cannot explain step by step, but it essentially tells that we take the header of all the files, so the first row, and then we kind of paste the files like one under the other. It would only work in case your files have the same header, so the number of columns is the same, and the order of columns is the same. So what it does is like putting these files together, treating them as data frame, and then that's the result, our data file called DAT, because this is how we named it. So we have the column names, and then we have the type of problem and some variables, some columns not super useful. For instance, these are described. These are characteristic only to practice sessions. These are only considering the actual trials, not the practice ones. This is something like an instruction, I think. Yes, this is like the instruction after the practice session, which we probably don't need, and so on and so forth. And then, yeah, and as I say, like such pieces of code can be simply found by Googling, for instance, loading multiple CSV files into R. And then you would find Stack Overflow post about this, and you just try. Here we can see that the files have been imported and transformed into a data frame called DAT. And yeah, we just clicked it. We've seen how this looks like. We can also remove the objects that we don't need anymore so that we are only left with that. So we have like that list and files, and we can remove them from our workspace here. Okay, they disappear from here. Technically, it doesn't change anything unless, okay, it frees up some memory of our computer. In our case, it didn't matter much in a sense that yeah, well, we have it cleaner here for our like more or less cognitive processes rather than for like making it easier time for R itself. So looking at this file, and it's kind of typical if we have run some like CyclePy or Open Sesame or ePrime stuff. We have lots of rows that we don't need, and there are also some columns that we don't need. So if we look at here, it's like 3 first rows for each participant are practice session. And imagine that we are not interested in practice session, we want to get rid of it. Fourth row for each participant corresponds to the instruction which happens after the practice session, right? So this is this one. It's like nothing except the columns which are about the text 2, which is the instruction after the practice session. And then we also have this row, which refers to the thank you message. So like, thank you for your whatever participation in the experiment, blah, blah, blah. We don't need it. So, of course, this changes from task to task and from the program to program. So, but the common thing is that usually you have some rows which are not relevant and you don't want to like aggregate them and so on. And then we need to figure out which rules to formulate to get rid of those rows that we don't need. So in our case, we can see that rows corresponding to the instructions and thank you message have an empty cell in the column called core ans. Thus, excluding rows with NAs in this column will solve the problem. We would just get rid of all the rows that we don't need. So we create a new filtered data frame, and we only include rows which do not have empty values, that is NAs in the column. So we use this like drop NA function that Hugo used, and we can use it this way. So we we can see that we decrease the number of like observations that we have by 6. And it means that we skip the instruction, the thank you, instruction and thank you for 3 participants, which sums up to 6 rows. Okay. So we see that we have like the now that we want to exclude we would like to exclude the rows from the practice session. Okay, because we now got rid of the instructions, but we still have columns with like rows with the practice session, and we have rows with the experimental sessions. So we do it again, checking where we have like empty spaces for the practice session, for instance, here in one of these columns. So if we say, okay, get rid of everything where this column has a value of NA, we just kind of do it this way. So we can use it this way also. And then again, we have 72 observations now. We don't have practice sessions, we have only experimental trials. But again, it's a bit complicated and annoying because we have those columns which are completely empty. And we don't need them because they're kind of like messing up. It's like for our visual inspection and like checking whether the data set is correct, we don't want them. So we want to get rid of this like empty columns. And this is the solution that I managed to Google. And this solution leads us to kind of getting rid of columns which don't have any data in because they were like devoted to either the thank you message or the instruction or to practice sessions. And now we have more or less data set which is at least more useful for us, right? Now we want to do the magic, so to say, because we want to learn, assuming that we are not willing to play around with linear mixed models or so, but we just want to aggregate the data in a sense that for each participant and for each condition, we get the mean accuracy. And we can do it, for instance, like this. So now we created a new data frame called ACC by condition. And it has 6 observations of 3 variables. So we have participant, type of problem, carry versus non-carry, participant 2, carry, non-carry, carry, non-carry. And if you remember, accuracy is coded 1 for correct response, 0 for incorrect response. So if we calculate the mean of this, we end up with like mean accuracy, which is also like a whatever proportion, percentage, or whatever. So this was just a simple bit of code showing how to aggregate like one column, which is demonstrating just the principle. So we go with like that filtered, we group it by participant and type. So participant denotes the subject code, type denotes whether it's carry, non-carry problem, And then we summarize accuracy equals mean from accuracy, and we tell to like not to consider the empty space. And then we can also combine it and create already within like one bit of code a data frame, which is aggregated by condition, that we first group by participant and condition, and then we summarize. I here use this like Doppler one just to be sure that the proper package is used. I know that it would be, but still this, to show how to code such a thing. This is like to prevent this like double names of functions between packages that you should be like wary of. And then we calculate the mean accuracy and we put it into column called ACC in our new data frame. We calculate the mean reaction time, but only for correct answers. We select only we calculate the mean for key RT started. That's our reaction time column, let's say, in this data set. And we select only for this aggregation, we only select rows for which accuracy equals 1. And then we also create a column called how many, which would tell us how many trials altogether we have per condition. It might be useful to check whether there was no like incomplete data sets, for instance. And then we can also check how many valid trials for the reaction time accuracy, for the reaction time aggregating we had. And for this, we calculate the sum of the column accuracy, which means that we calculate. Oh, I lost my plot. Yeah, so we have like accuracy, reaction time for corrected trials, how many trials altogether, and how many valid, that is those where the accuracy was 1. So let's do this. And from this, we can like aggregate it ICC by aggregated by condition. And here we see that we have columns, participant with the participant code, right? Then type, condition, carry, no carry, accuracy for each of them, reaction time correct for all of them, mean, how many trials we have in each category, and how many valid trials have been included into the reaction time analysis. So that was quite neat in a sense, like how many lines of code you need to get from the like bunch of files from CyclePy to the more or less organized data set. If we want to run, for instance, t-test on this like compatible like carry versus non-carry trials, we could if you don't want to use pipe, you could get something like this to get this ACC by condition. It's a bit more complex to read. But now we want to like flip this from the long data to the wide data. Why? Because, for instance, we want to run it in like Jamovi or the old school type organization of the data set to run the t-test, or we feel better to have the wide data for some reasons because we are old-fashioned or so. Then what we would like to do, we would like to have like 1 row per participant, and then to have like accuracy carry 1 column, accuracy no carry another column, RT correct carry, RT correct non-carry, how many carry, how many non-carry, and so on. And we can do it quite easily because hold on. Summarize. Oh yeah, here. So we use the pivot wider function that we've already seen in the previous example, where we say that we take names from type, values from, and then we say that we want to have values from RT-correct, ACC, how many and valid RT trials. And if we do this, we see that our data set already looks quite neatly. It has all we need. And then we could use like the old school style t-test in R, or we can move it to Jamovi or to JASP or anywhere. And we can just use like t-test carry, non-carry, like per t-test to check whether there is a difference between the two conditions. Of course, it doesn't make sense with 3 participants, but it's just to show you the principle. It would work for like 302. And then what else we want to do in such case? We might also, apart from the PsychoPy study, we also might have some whatever questionnaire data that these participants filled in, and we want to put it together that we have it all in one place, results from our study 1. So imagine that we have this questionnaire data in a file called questionnaire data.csv. So we can load this file to our workspace, and we see that we have like 3 observations with these participant codes, of course, corresponding to our participant codes from the raw data. And we have some data with about their whatever age, gender, and mathematics anxiety, let's say. Okay, and then to do this, we can use the function called left join, which says like that we want to combine aggregated by condition white, the one that we just flipped recently, then the questionnaire, and then by, and we provide participant. It means that we are having both here and here subject code, participant code in a variable called participant. Okay, so this means that it kind of takes and matches the values from one data frame and the other data frame based on this subject code. Okay, and then we can do it this way. And then our data complete file is, like we see that we first joined the aggregated by condition white and then questionnaire by participant. And then our data complete is first what we had in this data from our reaction time task. And then we have our age, gender, and mathematics anxiety from the questionnaire external study. And exactly the same we can do if we whatever run calculation task and whatever numerical Stroop task and something else, and then we want to like put it together if we want to whatever run some regression or some structural modeling or whatever. But in all the occasions that we need to like look into results of different tasks or data from predominantly different sources. Okay, and then the last step would be that we are quite happy with this, and then we decide, okay, we're done with R, we just want this, the further analysis to be done in Jamovi or in JASP or wherever, or we just want to have this data file for, I don't know, our bachelor student to analyze in whatever JASP for their thesis or anything like this. We want to have this nice file with everything aggregated already there, like that you can load to anywhere. So we can then use a function called write table. We say that we want to save the object, the data frame called data complete. We want to save it as a file the preprocessed data.txt as with the dot, like full stop as the decimal separator, columns separated with the tab. We want not to keep the row names, but we want to keep the column names, and we don't want every value to be in the quotation marks. So we run this, and we are done. Our pre-processing is completed. We have pre-processed data, which looks like this. We can open it maybe in Excel. And there you go. We have our nicely pre-processed data ready for analysis, ready for whatever further inspection, or so just done. And we with this, yeah, well, at the first sight, probably a bit longish and complicated code, but at the same time, in objective measure of how many lines we use, it's not so much. And doing it in Excel and figuring it out step by step would be really tedious, and sometimes it would require doing this for like every single part, some things for every single participant separately, rather than like even doing this like Excel merging thing and so on. So I think it helps, and it also gives you the freedom and benefits of reproducible workflow. That is, you skipped the column that you thought that was like completely useless because, I don't know, you thought that it's some stupid diagnostic feature of the E prime or psychopy or so, which was not relevant to anything. But then you realize that you have really weird results, and then you read the documentation of psychopy, and you were doing whatever, some subliminal priming, and this column would be, for instance, I'm just like making things up now, but for instance, imagine that this column is telling you whether there was some glitch in the display or not, that the subliminal prime was not displayed at all. And even though it's like sort of important information, like whether the subjects were exposed to the stimulus or not, and it might affect your results, and you might wish to have it in your data set. What you do, you don't need to do like everything. You just get to the line where you skip this column, and you just like add not to skip it, or like delete the bit of code which was deleting this column. And then you can end up with like keeping this column at every subsequent stage of the analysis. Any questions? I'm done.
Thank you so much, Krzysztof. That was very clear. So I hope everybody learned some useful tips and tricks on data pre-processing. If you have any questions, I think we can keep the chat open a couple more minutes. If not, thank you so much for being here. And then we will post the video on the MCLS YouTube channel, so you can look back at it again, and you have all the material that Krzysztof has provided, so you can also get in touch later if you still have questions.
Yeah, thanks so much. I hope it was not too boring, and I know, and like I really appreciate that you spent the 2 hours. It's like Friday afternoon. So yeah, thank you so much. And
yeah, so lots of thank yous, and there were some thank yous as well from people that had to leave after the first part that said that it was very useful. So I think they enjoyed it.
yeah, good. And thanks so much, and yeah, see you around.
Yeah, have a great weekend.
You too. Bye-bye.
Bye.
Bye.